In this video, we'll be looking at the different three-dimensional figures that you may come across in the future. So, one big thing is that a lot of people have a hard time distinguishing from object to object, like what type of 3D object am I looking at? And for that reason, a lot of people use the wrong formulas to find volume or surface area or whatever it is. So first and foremost, we just want to know what the figures are. So on this page, what we're looking at is a bunch of prisms. All right, so let's write that down. And what makes these prisms? Well, a prism is a solid with two parallel congruent bases. So what do I mean by parallel and congruent bases? Well, in the red figure, we have one base over here. It's a triangle. And in the back, there is actually, you can't see it, but let's trace it out in black here. You can't see it, but there's a triangle that is the same. It's congruent, same size, and it is parallel. It's standing up in the same way. So there are two parallel and congruent bases there. In this case, there is the same, two parallel congruent. In this case, we have 6 sides, so two parallel and congruent hexagons. We have two parallel and congruent squares in this case. We have, again, two parallel and congruent pentagons. So yeah, we're just practicing the names of shapes, and who knows what this is right here. It has many, many sides. All right, so that's one of the conditions to being a prism. It has to have two shapes that's the same from end to end, so parallel and congruent. Another thing is that these two faces have to be connected by parallelogram faces. So in our triangle prism here, or triangular prism, the two triangles, the one at the front and the one at the back, are connected by parallelograms. There's a parallelogram on each side. So there's one on the right, one on the left that we can't see, and one at the bottom. And that's the case for all of the figures on this page. We have, let's look at the hexagon. On our hexagon, we have parallelograms here connecting the hexagon at the front and at the back. So there are a bunch of parallelograms connecting those two parallel and congruent sides. So as long as we have the two faces that are the same, parallel and congruent, and those parallelograms joining them, then you know you're looking at a prism. Now, I could take my prism and I could stand it up. So let's look at the triangular prism because that's easiest to draw. I could stand it up like this, or I could lay it down like how you see it in red. It's still a prism. That's the base. Whether or not it's standing up or lying on its side, that shape is the base. All right, let's look at another figure. Okay, so I spent a lot of time on prisms because a lot of people mix up prisms and pyramids. So what is the difference between a prism and a pyramid? Well, a pyramid is a solid that has a polygon base, just like the prism had a polygon base, but they have 3 or more triangular faces that meet at one vertex. So instead of having a congruent side on the other end, instead of having 2 bases, it only has one. So in this example, the base is a rectangle, and then from a rectangle, there are 4 triangles. 1, 2, 3, one at the back, one at the side. There are 4 triangles that meet at a single vertex, at a single point. So it doesn't matter what shape that base is, because now we're looking at a hexagon right here. So our base is a hexagon, and that's fine. From each side of our hexagon, we have triangles once again, and the triangles meet again at a vertex. And it doesn't matter what that polygon is, as long as, so we have a polygon base. So let's write that down. Polygon base and triangle sides. So that's a pyramid. All right. So now that you've seen them back to back, hopefully you see the difference between a prism and a pyramid. Let's keep going. Okay, so now we are looking at a cylinder. And when I see a cylinder, the easiest thing for me to visualize is a toilet paper roll, an empty toilet paper roll. So when you see that empty toilet paper roll, what you're looking at is a cylinder that is nice and open. If you think of a cup, for example, like a perfectly, shaped mug type cup, it's closed at the bottom and open at the top. And if you think of maybe a tennis ball holder or something like that with a cap, then that is a closed cylinder. So you have your cylinder, it can be open at the top or open at the top and the bottom, it varies. But a cylinder will always have that toilet paper roll shape. Okay, so now we are looking at a cone. And more than likely, you've probably seen a cone going this way around, and you've probably had ice cream in that cone. So yeah, that's exactly the shape. A cone, the same thing that you would put your ice cream in. Or maybe one of those orange markers in the street. So yeah, that's a cone. It has a vertex. Oops. It has a vertex and it has a circle at the base. And even if I turn it upside down, it's still considered the base. It doesn't matter if it's that way around or this way around. Why I shaded in red is still the base. Okay, so now we are looking at a sphere. And a sphere looks, when I visualize a sphere, I think of a ball, like a basketball, something that is perfectly rounded. It has no vertices, it has no edges, it has no faces, it's just a ball. So if this is the center of my sphere, every point on the sphere, every point that we can touch is an equal distance from the center. So that makes a perfect ball shape. And so that's a sphere. And we're done with identifying our figures.